So we just went through this. We analyzed the server and the client example. So what now? Where do we go? Where do we go from here? How do we take this example and we make something out of it? Well, let's go back to the server example and let's look at some things here. Let's go to the beginning. Let's go to the start listening method and let's look at this portion right here. Just this part. The actual connection accepting. Now, in a real application, we really couldn't do something like this unless we design the application around it. So what I would do in this case, for something like this, we can make a class named, say, listener.cs or TCP listener.cs. This would be a better example since we're using a TCP socket. And what this thing could do is handle the listening and acceptance of incoming clients. So this thing right here, this block of code, we could wrap up into TCP listener to handle all this stuff for us. And we could have events, which could be socket accepted returns a successfully connected client socket. And that would really be all the TCP listener would have to do is accept a client and then continue on the loop. And this would also work asynchronously, so the rest of our application could function while this is accepting connections. And we could handle the accepted connection that comes through with the socket accepted event. Now let's go down to the accept callback. All of this will be handled inside of here. And then we can call something like var listener equals new TCP listener. And we could pass maybe the port in the constructor, since we really wouldn't have to change it midway. So we could pass like port 1234, for example, and we could have an event, or take our event, socket accepted plus equals listener socket accepted, and we have our event handler here. Actually, as a matter of fact, let me just put a little fake entry point here. Okay. We have our callback method, which would be listener socket accepted. Would have the sender in case we needed that, and socket accepted event args. I've been using the event args structure a lot lately, and I like it's a little more work, but I like the setup of it. So, for example, this is just us thinking about how we could take what we have here and wrap it up into something that we can reuse. So to just keep that in mind, this is all just pseudocode and just thinking of how we could do this. So after we have our callback set up, we will call listener.start. And every time we got a new connection, e dot accepted socket, and then we could do something with the client after we already accepted it. Now, after the client's been accepted, let's go ahead and talk about receiving the information, what I was having a little fit about a few minutes ago. This portion right here. Sure, we can accept the client, and then we can pass it around and all that other good stuff. But I personally wouldn't want to do this every single time I accepted a client. So what we're gonna do here is, instead of our TCP listener, and actually let me go ahead and give you an example of what I mean by this. We would inherit event arguments, public socket, accepted socket, get and private set, public socket accepted event args, leaves the accepted socket as the parameter, accepted socket equals S. So this would be our event argument class that we would use with this. Let me go ahead and show you that as well, just so you get a better idea of what I mean by this. So usually if you want to do an event, you can do something like delegate void socket accepted event handler object sender and socket accepted event args e. We could do that, but instead of having to make a new delegate void, since we have to make another class anyway if we want to pass more than two things without the parameter list getting out of hand, what we can do instead is public event handler socket accepted event args socket accepted. That's it. And then we would have public void start, but we're not going to actually code that right now. This is just pseudocode and coming up with a structure for our application. But going back to this, event handler is already a pre-made delegate in .NET, and all we have to do is pass a class that inherits event arguments, and we already have our event handler. We don't have to make any more delegates or anything else. All you have to do is make a new class that inherits event args, and we're good to go. And we can have as much stuff as we want inside of our event args class, and it's all wrapped up and all nice and clean. So this is us getting our listener all set up. Now, how are we going to handle the socket itself? Well, what we could do with that is there already is a TCP client, so let's call it. Naming is the one thing I suck at. It's TCP. Let's call it TCP socket, just because. There already is a TCP client, but we'll name ours TCP socket, just so things don't conflict. And this will handle I/O operations and disconnection, socket cleanup, etc. Oops, and also data management. data management, data structuring, ordering. I should say maybe data ordering. It'll handle the information in the data for us. Now, what I mean by this is once we accept a connection through the TCP listener, we're going to stick it in our TCP socket class, which will handle the rest of the stuff for us. And how we could do that could be something like TCP socket private socket S will store the socket that we pass through the constructor. Now, I can't really tell you how to think this way or how to approach a certain situation. It really is all how your brain interprets things. I'm just trying to give you a set base of how things can come together, but I'm not sure how I can actually transfer my processing into your own brain based on how you think. It really, it's all based on that. I'm just trying to give you a little guideline of how you could think of this. I'm not saying this is how you're going to think of it, or how this is how you think of it, this is the best way, this is how you do it. This is how I do it. And hopefully you're following suit, and slot A is going into slot B, and slot B into slot C, and things are starting to get a little more clear with how I'm demonstrating this. So what I'll do is take the path socket and stick it into the variable inside of the instance of the TCP socket. Now, with the receiving, this is where we're going to handle our receiving. Now, what I would do in this case, instead of having in the file, what I would do is send the length of the buffer that's being sent, and then the data right after it. And what I mean by that is once the instance is instantiated, I'm going to make a private void named begin read, and then I'll call begin read from the constructor. Now, what begin read will do is it'll start reading. It'll start the begin end receive loop. And what we'll do also is instantiate the buffer for the TCP socket. And let's go ahead and create our buffer size, constant variable that we're going to use for our buffer itself. After instantiate our class, right after we set our socket, we're going to go ahead and instantiate a new buffer based on the buffer size. And then we'll call begin read. What begin read will do is, again, like I mentioned, start the read process. So we'll do socket.begin receive, and you can follow along if you want to, or if you have been following along. This is just pseudocode. What we actually do might be a little different, but it's probably not going to venture off from this too far. So we'll call begin receive, buffer, 0, so forth and so forth. And our read callback, 0, and we don't have to pass a state, since everything is going to be a variable in our class. And we'll also have our read callback. Another point I want to make, when you have to use a try-catch, even if I mean, unless you know for a fact this try catch is going to trigger and you don't care about it whatsoever, always write the stack trace. Don't make the same mistakes I would make and just put try catches everywhere, and then when your program does have issues, you have no idea where it is or what's causing it. So all it says is an exception was thrown, an exception was thrown, an exception was thrown, and then you have to go through and remove every single try catch before you know, so the program can crash, and you can figure out what's causing it and where it came from. Always write the stack trace. That's one good thing I like about Java. If there's a possible exception, it will not allow you to compile it without putting a try-catch statement and writing to the console. That's the one thing I like about Java. The one thing. Anyways, we will write the stack trace, and then, like we saw beforehand, when we call in receive, we're storing the bytes that are read. Read equals s.end receive AR. You don't have to use this, but I personally like using this so I know what variable is a member of the class and what variable is a member of the method, so I know what's local and what's global. That's the main reason why I always use this. You can use this if you want to. If not, up to you. Now, this is where things are going to get a little different from what we were doing here. Since we would be sending the data with the size of the buffer in mind, or the size of the full data in mind, and as a matter of fact, let me do that first. We'll do our send method. So private void send, which would be our buffer that we're going to send, or just name this bytes. Now, since we may be using this in a multi-threaded environment, and two messages might be sent at the same time, or almost at the same time, we need to make sure only one instance of the data is used at a time, or we have to combine the 2 bytes together. And depending on the size of the data, we could just combine them and then have the garbage collector deal with it later. But I'll show you 2 different ways you could do this. I'll show you a few different ways you could do this, actually. But let me go ahead and stick this up here, because I might use this later. Send sync is the new object. And this won't be used for anything other than syncing, which I will show you in just one moment. But this is one way we could handle sending of the size and the buffer together. We could make a new list of bytes. And also before that, let's go ahead and get the size of the data. So we're going to have our size buffer equals new byte. Wait, no, it's not good. It will be bit converter dot get bytes. Bytes dot length. Now from here, what we could do is get our byte list, and then we'll add range, our size buffer, and byte list dot add range again, which would be our bytes, and then we would call begin send on our socket. Let's get the full buffer equals byte list dot to array, we're going to full buffer 0, full buffer dot length 0, send callback, and null. So this is one way you can send the data together. You can make a list, add in the size buffer, add in the bytes, get the full array of the byte list, send the full buffer, along with the length, send callback, and then null. Another way we could do this, if you don't want to merge them together with a list, again, we still need to get the size buffer. I'm just going to go ahead and copy this because I'm lazy. And then we'll make a new byte full buffer equals a new byte array that is size buffer dot length plus bytes dot length. So we're making an array that's large enough to hold the buffer size and the buffer itself. And we're going to use buffer.block copy. This is for manipulating byte arrays and such. Wait, is it source first or is it destination? Yeah, this is when IntelliSense comes in handy. I always forget, is it source first or destination first? Source and then destination, okay. So back to this. The source would be the size buffer starting from 0, the beginning of the size buffer, into the full buffer, 0, since it's going to be written right at the beginning, and then size buffer dot length. And then we're going to do the same thing, but in a different area. Block buffer, block copy, I mean. I've gotten too used to IntelliSense and correcting my stupid mistakes. And now we're going to take our bytes, 0, from the beginning of the byte array, of the data array, since we want to make sure everything is copied, into a size buffer dot length. Now remember what I was talking about earlier with the text and the indices when we were talking about index of? Same thing happens here. All arrays are 0-based. So if we already wrote 4 bytes to the beginning of the full buffer, that means we need to write on index 4, which goes 0, 1, 2, 3. That's the first. Let me just illustrate this instead of using my hands, since you won't be able to tell this anyway. So if we were sending 10 bytes of data, including the size, then we need to make a buffer that's 10 bytes. And we're putting the size into the first 4, so 0, 1, 2, 3. We're using the length, which would be 4, and since the indices are 0-based, this is right on the other 6, where we write the rest of our buffer. So that's why I'm using size buffer.length as the destination. And I realize I have it in the wrong spot. This needs to be full buffer and then size buffer.length. and then bytes dot length to copy the rest of the file. Now this is where the lock would have to come in. Actually, no, this isn't where the lock would have to come in. Then it would still be begin send. Now another way we could do this would be by not even doing any of this other crap that we've been doing, but by simply locking it. But if we lock and sync it, that means we're going to have to use send, and that would be the fastest way to actually deal with this. If we use begin send, then we have to wait for it to call back. Then after it calls back, then we have to call begin send again for the actual data, or we would have to call begin send on the size, and then in the send callback, we have to send the rest of the data. But no, we'll just do it like this. What we're going to do is call lock send sync. Now, what lock does is this is basically like someone only being allowed to be in one spot at a time, or waiting in line. This is basically waiting in line. So if, say you have a chat program, and then you send 5 messages at once, just rapidly, bam, 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 like gsend, 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 something like that. And all those happen on multiple threads, and then all those threads want to call send at the same exact time. Well, let me go ahead and show you the code outside of that. We would call this .s.send. Let's go ahead and grab that. Since we're sending everything, we don't have to worry about the other parameters. If I remember correctly, I don't remember sockets. I've been using the speak clients more often lately. Sockets, do I have to do? I think that's the case. I think that's fine. And then we would also call this IntelliSense will yell at me later if that's not the case. This is just pseudocode. And then we send the bytes. Now, if this is in a multi-threaded environment, what will be the problem here?